Bismillahirrahmanirrahim. So we started to talk about chapter 9, about subnetting, and we talked about the motivations for subnetting is to create smaller broadcast domains to minimize the overhead of the broadcast messages, and also to create some kind of isolation between the networks, so that any node that is compromised does not affect all the other nodes in the network. So, so starting from today, we are going to work on some exercises, just calculations. And all these exercises are revolving around subnetting and how can we calculate or plan these subnets. How can we calculate the number of subnets, the number of hosts per subnet, and so on. So these exercises are not new. So again, we are required to calculate the network. This is the network address in binary. So this is an address, and this is the subnet mask. So the only difference with chapter 8 is just this word, subnet mask, instead of network mask. That's the only difference. But the exercise is the same. So what we have learned in chapter 8 is that anything that's ended with 0 is 0. Anything that's ended with 255 is, in fact, the same thing. So we need to focus on this byte or this part of the address where some of the calculations needs to be done carefully. So basically, this is so in order to calculate the network address, we put here 0 and we put here 10 and 230. So this one is 109 and this one is 252. Same exercise that we've done before. So for 252, as we said before, it has only the last two, the least 2 bits are 0. When these 2 bits are ended, and we know that 109 is an odd number, so we put here 108. Okay. So this is supposed to be here, right? So this is in binary, but we don't have to do the binary. We can just do it in decimal right away. So here we are required to calculate the number of hosts per subnet. Okay. So right now we're talking about one subnet, but later on we will be able to, or will be asked to calculate how many subnets, what is the IP address of each subnet, and what are the number of hosts per subnet for each one. So here we are required to calculate the number of valid host addresses, and you need to focus on this part. Host addresses and not addresses. If I tell you addresses, then خلاص احنا we calculate the number of bits allocated for host, and 2 to the power this number, then we calculate the addresses. But host addresses is slightly different. Host addresses, which means that it has to be a valid host address. So network address is not a valid host address. Broadcast address is not a valid host address. So in which case here we have 6 bits, so 2 to the power 6, minus 2. It has to be minus 2. Okay? ماشي كده؟ That's a refreshment يعني. Type. Same thing here. So the number of bits allocated for host. Of course, I will give you this in decimal. Okay? Or in fact, this question can be shortened significantly. I tell you what is the number of host addresses for /29. That's it. So all this is actually can be summarized in this number. So /29 is equivalent to all of this, right? So it's 2 to the power 3, minus 2, because it's host address. Okay. Type. So 240, we know that 240 is 1111 and then all zeros. So this is 4, so 2 to the power 4 minus 2. Okay? So very straightforward so far, right? It will be harder and harder. Type. Here in this exercise, we are required to first calculate what is the first usable host address in this subnet. Okay, so this subnet is actually here defined by two things: the one address and the subnet mask. Of course, I can tell you instead what is the first usable host address in like this: 192.168.172.157 slash 28. صح كده؟ slash 28. Okay? So this is equivalent to this. And in fact, in the exam, I will give you this. I will not give you all the binary equivalents and all. Okay? So we need to calculate the first usable host address, the last usable host address, broadcast address, and this is the network address of the next subnet. That's new back. This one is new. So as we said before, we actually divide a range of IP addresses into subnets. So these subnets are contiguous, which means they are يعني one after the other, right? So these addresses are continuous. So first we need to calculate the network address of this, because obviously this 157 has some ones in the host part. So obviously this is a host address. It's not a network or sub-network address, right? Because the host part is not all zeros. Okay? So first we need to calculate the sub-network address of this network. But that's not one of the requirements here. The first requirement is not, in fact, the sub-network address. It's the first host usable address, not the sub-network address, right? And then we need to calculate the last usable host address, and then the broadcast address, and then the network address, not of this subnet, the next one. Okay? So any clue how can we do this? Any volunteers to do this? Mm-hmm. You can come here and do it if you like. Okay? Huh? Yeah, please.
Oh, right. So what I want to do is, for the first usable, we check for these guys, and we try for 001, and followed by.
Of course, this is binary.
Yeah.
But we are required to do it in decimal. So if you want, if you want to do something like this, then you can do it outside. So do outside, do all the sketching outside, and then you write the answer here.
Okay. Oh, I get
it.
So it would be something like 128 plus 16 plus 1, whatever that is. 4. Right.
Yes. Okay. That's good.
And the rest would be the same.
Yeah, but explain. يعني 128, because we have to make these 4 bits 0 first to get the network address, not the first user address. So what's remaining is this one, which is equivalent to 128, and this one, which is equivalent to 16. So 128 plus 16 is 148, and 144. Plus 1 is 145, because we need the first usable host address. Okay? Right? Then?
So, okay, I'll write it down in binary, then I'll convert it. It would be 1001 for the subnet.
And then?
111 and 0 for prior to broadcast.
Right. Right.
So whatever this is.
So you made it a little bit hard, but I will tell you an easier way to do it. Okay. So this is what.
Oh yeah. Okay. 239. No, not 239. It would be 144 plus. Whatever this is. Okay.
It's either 144 plus 8.
plus 14.
Plus, yeah, 14, yeah.
8, 5, 1.
Because 15 is 4 ones, right? 15 is 4 ones. So the one before it is 14. Right, yes.
And
Actually, so 159 is if we make it for all ones, this is a broadcast, okay?
it should be 1001 plus 1, right? Whatever that is.
It's actually plus 1.
Oh, yeah. Correct.
Because as we said,
go to next.
subnets,
Okay.
they have to be contiguous.
Yeah,
They have to come one after the other.
160.
So it's 160. Bravo. Yeah. So.
Thank
Okay, Kishore, right?
Yes.
Okay. Well, so an easier, slightly easier way to do it is just to say 1001 and then calculate the broadcast address right away. So when you calculate the broadcast address, you just say -1 is the last usable address. Okay. And the broadcast address is 144 plus 15. Okay, -1 is the last usable address, +1 is the next network address. And this network address, this is actually in fact a network address. Why? Because when you say 1001 and then 1111, this is a broadcast address, right? When you add 1 to this, all these 4 ones will become zeros, right? And the 1 will be added to, which is what you were trying to do, right? So all these ones will become 0. When they become 0, this is a subnetwork address. Okay? So when you add 1 to it, it becomes a subnetwork address. ماشي كده؟ طيب, same thing here. So we'll do it again. Okay? So again, the question is 192.168.163.61/ لا يا راجل, ليه 29? 24 plus 3. Right? So 2 to 4 is 3 ones and then all zeros. Plus the 24, it becomes 27. Okay? Type. What is the network? So the 60 is 0. Well, what we need to do is the first 3 bits. Okay? And of course, 0, you have 0, 0, 1, and then all zeros. This is what address is this? 32. Okay? So the subnetwork address is 32. So the first usable address is 33. So this is 33. And of course, this is 192.168.163.63. So this is the first usable address. Okay? The last usable address, we'll do it later, but first we do the broadcast address. The broadcast address is when we put all these 5 bits as 1. So it becomes 32 plus... Huh? 31. So it's, yeah, so these 5 zeros will become all ones, so it becomes 31. So this is 63. So the broadcast address is in fact 63. So this is 62, and this is 64. That's it. Okay? Well, any question? So you just need to practice, because in the exam you're supposed to do these things very, very quickly. And you will not have the luxury to just convert all these numbers to binary and take your time. So you have to do it very quickly. So luckily we have assignment to do this. So in the assignment you will do all these calculations exhaustively. And of course you have in the offline material you have lots of exercises related to this. So you need to practice how to do these calculations. These exercises are very, very easy. So we just need to calculate the prefix notation. So we say slash something, that's it. So what is the prefix notation? It's just to convert this decimal to binary and then calculate the number of ones, because this obviously corresponds to contiguous ones, and then the rest will be zeros. So again, this number is one of the numbers that we said we should memorize. So how many ones here? We have 5 ones. And then 3 zeros. So this is a slash 29, exactly. So this is 3 ones and then all zeros. So this is slash 90. Right? So you have 2 bytes, all ones, 16, plus this 224 is 3 ones and then all zeros. Okay, so 3 plus 16. Anyone who's not following how to calculate this? This is very, very easy. Okay. Okay, so that exercise is a bit tricky. So we need to. So the answer for this exercise, we need to calculate the longest subnet mask for this network. Okay. So the answer that we are required to do is just to say slash something. That's it. So this is the answer. Okay. So what is this number? So the answer for this exercise is just one number. But we'll see that this number is a little bit tricky to calculate. So this type of questions, you are required to put down all the steps you do it to come up with this number, because the number is just a number. You can just get this number from whatever, and even if if it happens to be correct, your answer will be wrong unless you put the steps. You put the steps how you did it. Right. So we need to systematically know how to calculate these types of questions. So first, how many subnets do we have in this network? 2. Yeah. In general, we have 1, 2, and 3. Okay? In general, we have 3. However, you have not been given any IP address here. So we need to focus on these 2. Okay? So we need to focus on these 2. Okay. So the other question is, these are routers, right? And as we said, routers provide separation, provide isolation between these networks. So we are requested to plan this as a separate network, this as a separate network. Okay? If I put here switches, then the answer for this is different, it's totally different. Because in that case, all of these are required to be one network. So there's no subnetting here, no subnets. Okay? So keep this in mind. Type. So in order to design a subnet so that it supports the fact that this is a subnet and this is a subnet and there is some kind of isolation, okay, then we need to fulfill 3 conditions. 3 conditions. Okay? So when we put a number, when we say slash something, this number has to fulfill these 3 conditions. One, the subnet address for each subnet is common. What does that mean? If you say let's assume that this is slash 30. We will come up with a subnet mask slash 30. Okay? So slash 30, we know that this is 254, right? 254 is 1, 1, 1, 1, 1, 1, and then 0, right? Sorry, 1, and then 0, right? It's just 255 minus 1. And here we have 225. 225 is in fact 224 plus 1, which is 0, 1, 1, 1, and then 0, 0, 0, 0, 1, right? So this is okay. Type. So if we say slash 30, then what this means is that we need to put the boundary here, right? So we have only 2 bits for host, right? If we do this, do we have, this is one subnet, huh? This is one subnet. One subnet means that it needs to have one subnet address, right? One subnet address, which means that if we put the host bits to 0, host bits can differ from one host to another. There's no problem. But do we have a common subnet address here for these 2 addresses? Do we? No, these numbers don't match, right? They are not the same. So we don't have one subnet address in this. So obviously /30 will not work. So this does not fulfill this condition. So /30 is not the right answer. Okay, type. Condition number 2 is that the subnet address for different subnets is different. Because someone might say, yeah, okay, so we have 169.22, 169.22, 169.22, 169.22. So it's very clear. And we have zeros. So /24 will work. /24 is common, right? But what is the problem here? لا, not only that. /24 will make this and this and this and this. All of them are part of the same subnet. Are they part of the same subnet? No, obviously they should belong to different subnets. Okay, so /24 will not fulfill that condition. So it's something in between. So now we are searching for a number in between the 24 and 30. Okay, so we can try about 25, 26. Number 3, the third condition, is that all addresses have to remain valid host addresses. So what does that mean? So if we say this, instead, let's assume that this is not 225. This is in fact 2 to 4. 2 to 4, okay? 2 to 4 here. So now, instead of this, we'll have this bit as 0, right? Okay? And let's assume that we will select 27 to be the prefix. Okay? In fact, if you see the condition 1 and condition 2, they are fulfilled. Condition 1 and condition 2, well, yeah, so they are fulfilled in that case. Okay? So the subnet for here will be different from here, and for each one it will be common. But what is the problem here? If we say /27, the 2 to 4 here will have all zeros in the host part, which means that it will not be a host address anymore. Okay? So if you have a network like this with assigned IP addresses, and all of a sudden you put the subnet mask /27, this host would not work. Because it's not a host address anymore. Assuming that this is 2 to 4, not 2 to 5. 2 to 5 will work, طبعا. Because 2 to 5 will have 1 in the host part, so it will work. Okay, طيب. Do we understand these conditions now? These 3 conditions, they have to be fulfilled. They have to be valid when you design your subnet prefix. Okay? طيب, how do we do it بقى? So far we did not answer the question. So how do we do it? Well, the best way is just to and this requires a little bit of calculation. Okay? So first, obviously we need to work on the last byte, صح? The first 3 bytes are straightforward. They are common anyway. So we just need to find a boundary in the last byte that will fulfill all these conditions. So obviously it's not 24, okay? And it's not 30, so it's somewhere in between. Okay? La, 27, it depends, because this is 225, not 224. And I'm just assuming, I was just assuming to explain. Yeah, but this in fact is 225, huh? It's not 224. This is 225. In the original question, and like, if it were 224, then this condition will not be fulfilled. But luckily, it's not 224. Okay, so we have flexibility. 27 might work. And in fact, it's actually the right answer. Let's see. So what we need to do is to take the last byte here and the last byte here. Okay, so this for this subnet, it's 254 is in fact 11111110, right? And the 225 is a 111 and then 00001. Okay, and then let's put a boundary here, because this is a one subnet. Okay, so let's put a hard boundary here. Okay, so these have to be common. And then the other two addresses. So 94 is in fact 0, and then 64, right? 64 plus 30, right? So it's 0. And then it's 30 is, it's 1, 1, 1. And then this 1, 1, 1. So this is 64 plus 30. And this is 30. Yeah, this is, I think it's like this. Okay. Yeah, someone might verify this for me. I think it's correct. But yeah, it doesn't matter so much. I will let you know why. And then 74 is in fact bardo 64, right? Plus 64 plus 11. 11 is 8. Sorry. Is 8 plus 3. Right? 8 plus 3. Okay? ماشي كده؟ طيب. So now, as we said, 24 will not work. So let's try 25. Okay? So 25, we'll put the boundary here. 25 is 1 bit after 24, right? If we put the boundary here, let's see if these 3 conditions are fulfilled. Are they? Let's see. Here, this subnetwork address is common because there is 1 and 1, right? This subnetwork address is common, okay? So first question is fulfilled. The 2 subnetwork addresses are different, right? Obviously fulfilled, right? So when I select 25, all these addresses are still host addresses, right? So all the 3 conditions are fulfilled, right? So let's try to put 25, and this is the right answer. No, it's not the right answer. Why? Because it's, yes. In order to verify that it's the longest, try 26, and it doesn't work. If 26 doesn't work, then 25 is the longest. Okay? So let's try 26. 26 will make the boundary here. Okay? Still, all the 3 conditions are fulfilled, right? صح? Because here 1 1 1 1, and this is 1 0 1 0 1, right? And obviously 1 1 is different from 0 1, so fulfilled. Okay? So it's 26 then. Well, we'll see. Let's try 27. 27. Still, all the conditions are fulfilled. Right? Right? صح كده? Okay. So let's try 28. 28 here is there's a difference. صح? So 28 is not the right answer. So what is the right answer? It's 27. That's it. This is the whole answer. Okay? So that's the right answer. But can I just say in the exam /27? Wrong. You have to do this. You have to put all these steps. Okay? Obviously. Okay, otherwise, يعني, you got this answer by inspiration and that will not work. ماشي كده? Any questions? So that's how we design a subnet. Of course, this exercise will be a lot different if I make one of these a switch. So you need to understand the concept. Routers create isolation between these subnets. Switches do not create this isolation. ماشي? So that's the method based on which we design these subnets. ماشي كده? Any questions? All right. So starting from here, we'll talk about some advanced techniques. It's not really advanced, يعني. So this is a host address, and this is a subnetwork address, and then we need to calculate the network address in binary and network address in this. Of course, we'll not do this. Let's just jump right away to the network address in decimal. Okay. So in that case, again, it's done by ANDing, صح? So here, this is a 0, and this is 172.27, and that's the only thing that we need to worry about. And of course, 254 has one bit, this bit is 0, and 55 here is an odd number, so it has the least bit as 1, so it becomes a 54, right? It's not worth really doing so much calculations. Anyone not following? Okay. So we're going through these exercises a little bit fast, and the reason is actually the fact that you will get really bored from these calculations, because on one hand you need to practice this a lot. So we'll give you a lot, many chances to practice these types of exercises. In the lab, you will learn this a lot. You will get many of these exercises a lot. Maybe some of you have already started doing that. In the assignment, you will also be asked to perform these calculations a lot. Okay, and obviously in the exam. Yeah. All right. Same thing here. So the network address in decimal based on this address and this subnet mask. So in that case, 248 has 5 ones and 3 zeros, right? You need to memorize these numbers, as I said before. Okay, so which means that these 3 numbers will have to be masked out, and these 3 numbers is 101, which is 5, right? So we just need to subtract 5 from the 133. Okay, so it becomes 10.44.175.120. 128, right? Yeah, 128. We subtract 5 from 133. Okay? Type. So this is again, same thing, number of valid hosts. I don't need anything other than this. So this is 128 has 1 0, right? One bit as 1, and all the rest are zeros. So it's 1 plus 16, so it's 17, right? From the 32 it becomes 15. So it's 2 to the power 15 minus, that's it. This is the number of valid host addresses, right? So we just need to calculate the number of bits in the host part. The number of bits in the host part, when the third byte is 128. 128 is just 1 and all zeros. So 1 plus 16 becomes 17. So the rest for the host is 50, right? Any difficulty here? This is very easy. Okay? It's not really worth حتى ان I ask someone to come and do it, and it's not really worth it. Okay, so starting from here we'll get a little bit more level of difficulty. Okay? So this is the net, so determining the valid addresses for hosts. So it's the same exercise that we have done before, but here you will see that it's a little bit trickier, just a little bit. So again, we need to calculate the first usable host address, the last usable host address, the broadcast address, and the network address. Okay? So to calculate, this is the host address, and this is the subnet mask. So to calculate first the network address, so we just need to put, this is 190 and this is 128, right? So 190 here is above 128, which means that it has 1 and then something. I don't care about something because this is actually 1 and all of these bits are masked anyway, right? So this 190 and 128 will be masked, and the network address will be 128, right? So it will be 172. I will put it here, not here, right? Because the question is asking for something else. So I'll put it here. So 172.21.128, right? 190 masked by 128 is 128, right? Dot 0. So this is the subnetwork address. Okay? That's not what the question is asking for. What the question is asking for the first host address. أيوة أنا كنت أيوة عشان إيه بقى؟ That's wrong. That's exactly what this question is for. And that's why there is the word advanced here. That's the only thing. It's just to put you into this trap. To say, okay, add one where? Add one here. Not here. Okay? So again, so here, the host part is the host part is 8 zeros. Here, this is 8 zeros. And in this byte, you have 7 zeros, right? And this bit here belong to the subnetwork address, not to the host part. So this is, in fact, the host part, not this. So the host part is in fact 15 bits, not 7 bits, okay? So you need to add one here. واضح كده؟ Okay. So here the answer is 172.21.128.1. Okay? طيب. What is the broadcast address? Yes, it's to put all these way ones. And this one is already 1, right? So it becomes 172.21.255.255. So this one is the one before it. So it becomes here 254, and this is 255, and this is 21, and this is... Okay? ماشي كده? Okay, what is the next subnet address? Huh? Bravo. Yes. So it's here, when you add 1 to this address, okay? These are 8 ones, these are 8 ones. So when you add 1 to it, all of these will become 0. So here is 0, here is 0, and this becomes a 22, and this is 172. Okay? So it's slightly trickier, slightly trickier. Okay? So with practice, this will become very easy, but you need to practice a lot. Any questions? So we'll do this determining the number of bits to borrow for subnet. Actually, we can do that next time, because this